For centuries, humanity has gazed up at the night sky, filled with wonder and awe. The stars, the galaxies, the vast nebulae stretching into infinity. They create a cosmic tapestry that seems, at first glance, perfectly ordered, almost serene. From our place on Earth, it appears that the universe is a grand, unified whole, bound by the same laws of physics across all its expanse. But what if this assumption is wrong? What if the universe, this magnificent expanse we think we know, isn't as uniform as we've always believed? What if the very fabric of space itself is uneven, chaotic, and unpredictable? What if the vastness of the cosmos is full of deep mysteries, far beyond what we can currently imagine? This question, one that challenges the fundamental ideas of cosmology, could redefine everything we thought we knew about the universe. It could change our understanding of space, time, and even the nature of reality itself. For centuries, scientists and astronomers assumed that the universe was, at the grandest scales, uniform. This idea is known as the cosmological principle, the assumption that the universe looks the same everywhere, that its structure and physical laws are consistent no matter where we look. This principle is the bedrock of modern cosmology, shaping everything from our understanding of the Big Bang to the expansion of the universe. It suggested that the galaxies we see, the stars, the nebulae, all are distributed in a relatively predictable way. No matter where we look in space, the same patterns of matter, energy, and physical laws would hold true. The universe appeared to be vast, yes, but organized. This assumption was so central to our understanding of the cosmos that it stood largely unchallenged for decades. But with new discoveries and advanced technology, the idea of a uniform universe is being re-examined, and we are now starting to uncover something far more complicated and surprising. What if the cosmos isn't as simple, as evenly structured as we thought? As technology improved, especially with the advent of powerful telescopes and satellites, astronomers began to notice something unexpected. The universe wasn't as uniform as we had assumed. Large-scale structures, including superclusters of galaxies and vast, empty voids, began to reveal themselves in our observations. In fact, the universe is anything but smooth. It is full of dense, sprawling regions of galaxies, known as superclusters, and massive, almost empty expanses called cosmic voids. These voids are stretches of space where galaxies are sparse, sometimes entirely absent. Some of these voids span hundreds of millions of light years. Between these galaxies, the differences in matter distribution are profound. Some areas are teeming with galaxies, while others are almost completely devoid of them. It was the cosmic microwave background radiation, the faint glow left over from the Big Bang, that first revealed these irregularities. When scientists looked at this radiation with precision instruments like the WMAP and the Planck satellite, they discovered small fluctuations in temperature. These tiny variations, each smaller than a degree, offered a glimpse into the early universe, suggesting that it began in a state far from uniform. Could these fluctuations have played a role in the uneven distribution of galaxies we see today? What if these seemingly small temperature differences were the seeds for the galaxies, stars, and planets that eventually formed? These discoveries mark a shift from a universe that once seemed orderly to one that might be far more dynamic, complex, and chaotic than we could ever have imagined. As we peer deeper into space, we begin to uncover the true scale of these irregularities. At first glance, the universe may seem like a vast, empty void punctuated by the occasional star or galaxy. But as we zoom out, we discover a vastly more intricate structure. The universe is not randomly distributed. It is shaped by massive, sprawling networks of galaxies. These networks form immense galactic filaments, interconnected threads of matter stretching across hundreds of millions of light years. These filaments create a cosmic web where galaxies clump together in dense superclusters and vast, empty voids stretch between them like cosmic deserts. At the other end of the spectrum, you find dwarf galaxies, tiny and scattered, existing in sharp contrast to the massive, bright spirals and ellipticals. Some galaxies are rich in star-forming regions, while others are ancient and dying. Their differences are not random. They might reveal a more profound story about the way the universe has evolved. What does this tell us about the cosmos? Could the early universe, which began from a hot, dense state, have developed into this complex, lumpy structure due to the very physics we take for granted? Or is there something deeper, something yet to be uncovered, guiding this formation? Adding to this complexity are the enigmatic forces of dark matter and dark energy. Together, these two invisible components account for more than 95% of the universe's mass and energy. Yet, despite their overwhelming influence, we have barely begun to understand them. Dark matter is a mysterious substance that doesn't emit light. Yet its gravitational pull shapes galaxies and holds galaxy clusters together. It is thought to exist in large, unseen clouds, clumping together in regions of the universe. If the distribution of dark matter is uneven, as some studies suggest, it could explain the strange, irregular clumping of galaxies and the web-like structure of the universe. Then there's dark energy, the force accelerating the expansion of the universe. What we know about dark energy is that it exerts a repulsive force, pushing galaxies apart. But its influence is not uniform. Some parts of the universe might feel the effects of dark energy more strongly than others, causing parts of the cosmos to stretch faster than others. Are these hidden forces responsible for creating pockets of irregularity across space? Could the distribution of dark matter and dark energy be the reason for the strange patterns we see in the cosmos today? The idea of a uniform universe also faces a radical challenge from the multiverse theory. Imagine that our universe, with all its irregularities and complexities, is just one of many, perhaps an infinite number, of universes, each with its own laws of physics, constants, and even dimensions of space and time. In this view, our universe is merely a speck in a vast, cosmic ocean, each universe within the multiverse potentially operating under a different set of rules. If this theory is correct, then the irregularities we observe, the strange distribution of galaxies, the pockets of empty space, the varying strengths of dark energy, could be signs of a much larger, more varied cosmos. Our universe might just be one bubble in an endless sea of realities, each with its own peculiarities. Could this be why our universe appears to be irregular, with some regions differing vastly from others? Could these variations be simply a product of our own cosmic bubble? And if we looked outside our own universe, we would find entire realities where things operate in entirely different ways? The observable universe, the part of the cosmos we can see and measure, extends about 13.8 billion light-years in every direction. But what if the universe beyond this horizon holds even more secrets? What if there are regions of space we can't yet detect, parts of the cosmos that have been hidden from us since the dawn of time? If the universe isn't uniform, then what lies in these unseen regions? Could there be regions where the laws of physics behave completely differently, where stars and galaxies form in bizarre ways, or where entirely new forms of matter and energy exist? Could the cosmos be far stranger than we can even imagine? If the universe is not uniform, it would challenge our most fundamental beliefs about the cosmos. It would mean that the universe is far more complex, more mysterious than we ever imagined. Every galaxy, every cluster, and every void might hold a deeper secret waiting to be unlocked. The irregularities could point to new laws of physics, new understandings of how the universe came to be, and new mysteries to explore. For now, we have only begun to scratch the surface. But one thing is certain: the quest to understand the true nature of the cosmos, with all its irregularities, is only just beginning.